Comptia Network Plus course. Introducing the OSI model. The OSI model was designed to promote interoperability by creating a guideline for network data transmission between computers that have different hardware vendors, software, operating systems, and protocols. For example, look at the simple process of transferring a file from a user's perspective. A single operation has been performed to transfer the file. In reality, however, many different procedures had to take place behind the scenes to accomplish this seemingly simple task. Network data transmission, like the file transfer, is performed through the use of a protocol suite, also known as a protocol stack. A protocol suite is most easily defined as a set of rules used to determine how computers communicate with each other. It is similar to language. If I speak English and you speak English, then we can communicate. But if I only speak Spanish and you speak only English, then we won't be able to communicate. The OSI model is used to describe what tasks a protocol suite performs. As you explore how data moves across the network, keep in mind that not all protocols map directly to the guideline provided for us throughout the OSI model, but there are enough similarities so that you can use the OSI model to examine how these protocols function. There are a myriad of protocol suites in use today, including IPX, SPX, NET, BIOS, and TCP/IP. Each performs a specific function. Many of these functions that are provided through the use of a protocol stack and its components are standard functions performed by other components in other protocol stacks. The most commonly referenced protocol model, the OSI model, was developed in 1977 by the International Organization for Standardization (ISO) to provide common ground when describing any network protocol, application, presentation, session, transport, network, data link, physical. As you can see, the OSI model consists of 7 layers. Each layer performs a specific function and then passes on the results to another layer. When a sending station has data to send, it formats a network request and then passes that request on the network protocol at the top layer. The application layer, the protocol that runs the application layer, performs an operation on the request and then passes it to the next lower layer. Each protocol at each layer below the application layer performs its own calculations and appends its own information to the data sent from the layer above it. At the receiving station, the process happens in reverse. The OSI model is not only a model, it's not only a protocol. Nobody is running the OSI model, at least no one has developed one at the time of this writing. Let's take a brief look at the layers of the OSI model and the basic protocol functions they describe. We'll start at the top with the application layer and work our way down to the physical layer. Application layer, the top layer of the OSI model, does not refer to applications such as word processors, but rather refers to a set of tools that an application can use to accomplish a task, such as a word processor application requesting a file transfer. This layer is responsible for defining how interaction occurs between network services and the network. Services that function at the application layer include, but are not limited to, file, print, and messaging services. The application layer may also support error recovery. The presentation layer is responsible for formatting data exchange. In this layer, character sets are converted and data is encrypted. Data may also be compressed at this layer, and this layer usually handles the redirection of data streams. The session layer defines how two computers establish, synchronize, maintain, and end a session. Practical functions such as security authentication, connection ID establishment, data transfer acknowledgements, and connection release take place here. This list is not all inclusive. Any communication that requires milestones, typically these milestones are called checkpoints. Once a checkpoint has been crossed, any data not received needs retransmission only from the last good checkpoint. Adjusting checkpoints to an account for very reliable or unreliable connections can greatly improve the actual throughput of data transmission. The transport layer is responsible for checking that the data was delivered error-free. It is also used to divide a message that is too long into smaller segments and in reverse. Take a series of short messages and combine them into one longer segment. These smaller and combined segments must later be correctly reassembled. This is accomplished through segment sequencing. This layer also handles logical address and name resolution. Additionally, this layer can send an acknowledgement that it got the data packet. Frequently, you will see this referred to as ACKA, which is short for acknowledgement. This layer is responsible for the majority of error and flow connection in network communications. The network layer. The network layer is responsible for logical addressing and translating logical names into physical addresses. A little known function of the network layer is prioritizing data. Not all data is of equal importance. Nobody is hurt if an email message is delayed a fraction of a second. Delaying audio or video a fraction of a second could be disastrous to the message. This prioritizing is known as quality of service. QoS. In addition, the network layer controls congestion, routes data from source to destination, and builds and tears down packets. Most routing protocols function at this layer. The data link layer. The data link layer takes raw data from the physical layer and gives it a logical structure. This logic includes information about where the data is meant to go, which computer sent the data, and the overall validity of the bytes sent. In most situations, after a data frame is sent, the data link layer then waits for a positive acknowledgement. If one is not received or if the frame is damaged, another frame is sent. The data link layer also controls functions of logical network topologies and physical addressing, as well as data synchronization and connection. The physical layer. The physical layer is responsible for controlling the functional interface such as transmission technique, pin layout, and connector type. So I'm going to leave it here today for this part of the Comptia Network Plus course. If you like this video, please consider like, sharing, and subscribing, and thanks for listening.